indicator shows the amount of stock removed from the specimen. But this measurement is not always accurate. In most instances, the drive ring loses negligible material compared to the specimen itself. To prevent cracks or chips occurring during lapping, increase the load gradually and closely monitor the process. By using a single-tube microscope, we can determine when the surface of fiber is touched through lapping. There will be an ellipse with a non-reflective surface on the fiber. The longer the ellipse along the fiber longitude, the closer the lapping surface is to the fiber cladding and core interface. To determine the distance to cladding core interface, use the liquid drop method. The lapping process can stop when you get a 1 to 3 decibel loss. The cleaning process is important because any particle brought over onto the polishing plate may cause excessive loss to the half block. This will affect the ultimate polishing surface quality. Use tissue to wipe the plate thoroughly before removing it from the machine. Use a controlled amount of water to wash away the abrasive in the drip tray. To clean the jig ring, once again use tissue to wipe before using water to clean it thoroughly. A toothbrush can be used to remove all the abrasive remains in the ring grooves. Clean the polishing machine thoroughly, especially the half-circle roller arm. Clean the plate surface thoroughly by scrubbing with a nylon brush and water. Rinse with deionized water. Clean the master flat block and the contact surfaces of the single dial gauge. Place the single dial gauge on the master flat block and set to 0. Moisten the surface of the polyurethane and carefully position the single dial gauge on the surface with the dial facing outwards and with the feet about 5 mm from the outer edge. Note the reading on the single dial gauge in this position. If the pointer is clockwise of 0, the plate is convex. If the pointer is anti-clockwise of 0, the plate is concave. Take at least 3 other readings in different positions. Be careful in comparing the dial gauge readings in positions 1 to 4. This will help in gauging whether the plate is flat, convex or concave. If the plate is flat, within 2 microns tolerance, it should still be surface conditioned by running a conditioning ring with polishing media for 20 minutes prior to the application of samples. If the plate is outside the tolerance limit, it must be corrected using the plate conditioning procedure. Cerium oxide is used here as the polishing abrasive. Mix cerium oxide and deionized water in a beaker and stir well. Cover it well immediately after use to minimize exposure to air. Put the jig with a lapped half-block sample onto the polishing plate with moderate load. Run the polishing plate at 10 to 20 RPMs for half an hour. During this time, dip the abrasive with a glass rod and sprinkle it onto the plate. Clean the half block carefully with soap water only before using liquid drop method to measure the power loss. Take note of the reference power reading first. Then drop on the liquid index and take down the new power reading. Use a patch cord connected to the laser source with the power meter to obtain reference level reading. If the loss is not what is required, then run the sample on the polishing plate again. When polishing is done, remove the half block from the jig and melt the wax with a heater to conduct further studies. Clean the plate thoroughly, seal it with a plastic wrap and put it into a Ziploc plastic bag. Clean the machine and workbench thoroughly.